Hi everyone, welcome back to Inside Data Academy. This is our second lesson in our MySQL Launchpad. In our last lesson, we discussed about the select and the where clauses, where we talk about the select clause is being used in displaying some particular feed. That is, we use it to pick out some particular feed in our table. Whereas we use the where as a conditional clause to select or to filter out as in some rows that met some particular condition in our table. However, today we'll be continuing from there. In today's lesson, we'll be discussing about some functions that are being used with the select and where clauses. Likewise, we'll also talk about the group by clause and finally the having clause. There are some functions that we do use with select clauses and where clauses. Some of them includes the following. We have the string function, we have the numerical function, we have the date time function. Likewise, we also have the aggregate function. So picking them one after the other. From the string function, some of the string function we have in MySQL or in SQL generally includes the upper function, which is used to convert a categorical data, that is a word, to uppercase, that is to capital letter. Likewise, we have the lower function also. It's also used to convert to lowercase, while we have the concat, that is used to join as in different string together. What do we mean by string here? String simply means text, alphabets, words. So let's do some example using this upper, lower, and concat. So let's move on to our MySQL workbench interface. Here's our MySQL workbench interface. Let's take, for instance, we want to convert some fields here into uppercase. We can simply do that by leveraging the upper function with our select clause. Take, for instance, the field over here, the first name and the last name. We can, instead of them being starting only with a capital letter, we can decide to capitalize all through. Let's say select upper. We want to change this row, that is the first name column, into all capital letter. So let's say this is first name. We close that. Enter. From the table we are using here is the customers table, that is customers over here. So let me put the semicolon there. If I run this query, let's see what you have. Control Enter. Okay, it throws an error over here. It says no database selected, the default DB to be used, double click its name, this. Yeah, in MySQL, whenever you want to start writing your query, you have to specify the database you will be using. You can simply do this by double clicking on the database that you've created. Take, for instance, we have the SYS, which is the system database, as in by default on any MySQL workbench or any MySQL software. This MySQL _Launchpad Launchpad is the database we just created. We have to select the database itself. You can do this in two ways. Is either you use a query to achieve that, or you can simply just double tap on the database itself. So let's say use the database, which is MySQL _Launchpad. Then let's run this. Control Enter. As you see, as I click, as I run this particular query, this first query over here, this MySQL Launchpad database, it changes to a bold as in color, meaning that it has been selected. You can simply use this as in this query to achieve that. That's the first way of doing that. Let me just deselect it. Take for instance, I want to select the MySQL Launchpad database. That's the database I want to be running all my query on. I'll just simply come to where it is and I'll double tap on it. And as you can see, it has been embedding. So I can simply now run this query without any issue. So Control Enter now. As you can see, all the names in the first names, you can see that it has already changed them to what? All capital letter. But we might also need some others as in column or other fields in this particular table, so we can include them also. Let's take for instance, let's say we still need some fields like, let me select all from here. Let me run this query particularly. Let's say we still need we needed the last name and the email, so we can simply include it here in our first query over here, comma. Let's say the last name also we want it to be in capital letter, so that will be upper. You can write as I said earlier on, as we said earlier on in our first lesson, that MySQL is case insensitive. You can decide to write it as in your function in uppercase or lowercase, so either way is correct. Let's say upper of last name, and likewise, let's say we needed their email also, so let's just include it there, that email, and let's run it and see what you have. You can simply highlight all and click on this button, this execute button, or you can simply just as in click anywhere on your statement and click Control Enter. Either of the two will work. Control Enter. So now we can, as you can see now, we have the first name being capitalized and also the last name being capitalized, and we have the email as it is. But however, if you see this particular column, you can see upper first name, upper last name. It's not making much sense to us or for the reader, for our reader. So we can simply rename this particular column to something meaningful. We can rename it to something meaningful. Let's say we want to rename this first column to, let's say, first name. Now, that's our new first name. So we can simply just say, we can simply use an alias. An alias in SQL is just like a temporary name that you are using to denote a particular field in your query. I call it temporary. It doesn't mean that you are replacing the initial name in your table. What do I mean by that? Let us simply implement that to see what I'm talking of. Use as your alias. Upper first name, alias it as first name upper. For instance, let's say first name upper. And this last name also, let's say we can alias it as last name upper. Last name upper. So let's run this and see what we have now. Control Enter. As you can see from here now, the table has changed from being just upper first name and upper last name to first name upper and last name upper. This is the work of alias. Alias changes the name of a field temporarily. Take for instance, if I am to perform any other query on this table, on this customer table, it won't change, as in the first name column won't change to first name upper. Likewise, the last name column won't change to last name upper. Take for instance, let me visualize, as in let me display the table again by selecting all from customer. Control Enter. As you can see here, the first name still remain as it is. Likewise, the last name also still remain as it is. However, the alias here is just to change the name temporarily in that particular query. In this particular query precisely. Control Enter. As you can see, it changes here. I can change it to anything of my choice that I know that it will be readable to, as in to me. So that's about the first function. That is the first string function. We can also use the lower function. Lower function is just the opposite of upper function. That is changing from from any case to lowercase, all lowercase. Coming back to this function itself, we can simply change this upper to lower. Let's say we decided to make all this capital letter name, we decided to make them all lower caps, or all lower case, I mean. So this will be lower, and let's change this to lower. Likewise, this also to lower. So, and let's run that. Control Enter. As you can see now, the first name now has changed from all caps to all lowercase. Likewise, the last name also. Another string function here is the concat function. Concat means concatenation, that is joining two tests together, that is joining two strings together. Let's take, for instance, we want to join the first name and last name together. You can simply leverage on the concat function. This is how it works. We use the concat function to join. Let's say we want to join the first name, that is the first name, comma, we will need some spacing as an in between, that is between the first name and last name, right? So we'll denote that using this quotation mark, then we'll space it as in single quotation mark, I mean. Let's say this space and another quotation mark, comma, then the last name. So let's simply close this up and let's run it. As you can see here, the first name was as in separate, is in a separate field. Likewise, the last name also is in separate field, but we want to merge them together, that is to have a full name. We can simply alias this as what? As full name. Let's say full name. So let's run this. Control Enter. Oops. Check the manual corresponding to MySQL. There's an error over there. Where do we make that error from? First name, last name. Let's check our initial table and see what we have there before. First name, last name is correct. Okay. Seems where the error comes from is that when we are selecting, we made that mistake of not putting comma over here before this email. That is, we want to select the concatenation of the first and last name, then and the email. We will only want to display the full name and their corresponding emails. So don't forget to put comma here next time. So let's run that and see what we have. Control Enter. All right, as you can see now, this is the full name and their email. Ronald Phillips, which was separated before as first name and last name, are now concatenated together. They are brought together. Let's move on to the numerical function. As it sounds, numerical. This only deals with numerical data, that is numbers. So you can use these functions with our numerical data, round function, to round up numbers to a particular decimal place. Likewise, you have the ceiling function. The ceiling function is used to round up. Then the opposite of that is the floor function, which is used to round down a number. Let's see how they play out in our MySQL Workbench interface. All right, so we are using the numerical functions now. Let's play with the first one over here, which is the round function. Let's use the product table, for instance. Let's see the product table. Product. Control Enter. All right, as you can see, here are some numerical function. Here are numerical data here, like the price column, the costs column. Let's take, for instance, we are willing to round up this price to the nearest whole number. Let's say, let me change this from customer to product. The product. Then let's select the product name, that is we want to display the product name. Let's say the category also. And finally the price. But now we are using the round function with the price. We want to approximate it, that is to the nearest whole number. Let's say round price, comma 0. What does this mean? The column we are selecting is this itself, price. That is the field we are selecting. So how many number after points, that is how many to how many decimal place, we selected 0, meaning that any number after decimal, that is to the nearest whole number. So we can simply run this and see what we have. Control Enter. As you can see, previously from what was being displayed on our price feed before, having decimal points, we've successfully rounded it up to the nearest whole number without any decimal points. As you can see, 264, 368 without any decimal points. We can simply still use another alias here in order for us to enhance the readability of this particular column, this round price column. Let's say this as, let's say, rounded price, for instance. Let's say rounded price. So Control Enter. So as you can see now, we have the rounded price column as like this. We can also decide to round it up to, let's say, 1 decimal point, that is one number after decimal. Just simply toggle this to change this to 1 and click Control Enter to run that. As you can see, it has changed again to one number after decimal. So the next numerical function here in our list here is the ceiling function. Ceiling, as it sounds, that is, you are going up, the ceiling of a roof, right? That is, we are going up. It's used to round up a number. Take, for instance, to the nearest whole number, precisely. Instead of us using comma 2, comma 3 with price, we can simply just change it to this, that is the ceiling function, seal price, that is round all these prices like this. Take for instance this 263.92, round it up to the nearest whole number. So let's rename this to ceiling price, or let's say seal price, for instance. So let's run this and see what we have. Control Enter. As you can see, this was initially 26.3 before. All was that? Let me check it out. 263.92 before, and now when we run this, it changes to 264. That is to the it's rounded it up to the nearest whole number. 23.9 is closer to 26. 263.9 is closer to 264. Right? That's just as in our basic mathematics. Any number that is 0.5 above, you can simply round it up to the nearest, as in nearest tenth. Then any number that is, let's say, 0.4 downward, like that, you round down, as in you round it down to the nearest 10. So using this ceiling function, it's rounded it up towards to the nearest whole number, 264, 268, and the likes. So the opposite of ceiling function is a floor function, that is to the nearest 10 but downward. Let's see what we have. Control Enter. 263 instead of 264. Right? It round it down to the nearest tenth. So that's about that. Let's move us next to the next function over here. Although there are many functions, but we are just taking some of them. You can also read more on several functions that you can use with select statements in MySQL or in SQL generally. So let's move on to the next function over here, which is the date and time function. This is being used with timestamp or dates and time, as in dates and time. We can simply call them timestamp. So there we have the year, we have the months, we also have now and the likes. So let's use the first one over here. Take for instance that you want to extract only the year. Let me display the full data for products. Let's take for instance, we're only concerned about the year in which our product is being launched alone. We only needed the year alone. We don't need the day, we don't need the month. We can simply use year to extract that out. This is what I'm saying. Let me illustrate it here. Let's say we have product category and everything like that as it is. We can simply leverage on the year function. Year function of which feed, that is the launch date, right? So we type that launch date. So we can simply alias this as, let's say, year. And let's run this. Control, or let's say year launched. And let's say control enter. Oops, it's through an error. It says launch dates unknown column. Launch dates in feed. Okay, seems like I made a typo error here. Let's end here. Launch dates. Control enter. All right, let me change this also to year launched. So as you can see here, we find out that these are only years 2023, 2024, 2025, like that. These products, Walker Outdoor, is being launched in 2025. These products, ITS Team Sports, is being launched in 2023. The Create Air Care products is being launched in 2023. As you can see, it's only extracted out the year out of what? Out of that launch date, out of the date. You can simply extract the year alone. And if you like, you can extract the months. Take, for instance, we only needed the months in which each product is being launched. We will just specify that we are selecting the what? The months. That will be the months. Then you will run this. As you can see, you have 2, 3. That is, this is in February. This was in December. This was in March, like that. And take, for instance, we want to check the precise dates of today. That is today's date. You can also use the now function. That is the now function over here. You can also leverage on that to know the initial dates. And that doesn't cause for as in pulling out from a specific table. Let's say, for instance, we want to check today's dates on our MySQL. We'll just say now, then we'll run that. So as you can see, we have today's dates and time. We can simply just as in clear this out and put our semicolon here and run it. Control enter. As you can see, this is today's date, 2025 August 17 11 14 blah blah blah, like that. So we can simply rename this. We can alias it as, let's say, today. So, and you can see here is it. So that's that about the dates and time function. So let's move ahead with the last function over here, the aggregate function. We are talking about aggregate. That is, you are grouping something together. You are compressing a row. We are compressing rows together to give out a single output. Some of the popular function that we do use, basically we do use this with group by, in which we'll be talking about after this. Afterward, we'll talk about the group by clauses, how to use aggregate function with group by clauses. So we have the count function, we have the sum function, average function, max, and min. Count, that is to count the numbers of rows or the numbers of items that's in question. Likewise, sum, that's just as in the total, the summation of all the feed we are calculating for. The average, that's the mean. Likewise, the max, that's the as in the highest, while the mean is the lowest. So let's do that in our SQL workbench. Let's take, for instance, now on product again. In this price, we might decide to know the total price of the good being sold. That is the total price. So let's leverage on that. On the firstly, before doing that, let's start with the count function first. Let's take, for instance, we want to count the numbers of products we have in our products table. So we can simply just use the count function. Let's say count the total number of products name we have. That will be product name, then close. From, we are pulling the data from the product table, so we have to specify it, product, then control enter. As you can see here, we add about 150 products in this our product name, although it might still repeat, as in we might have some repetition in there, that is some duplicates, but counting them totally, that is count all, it's what we have about 150 products. Let's say we are more concerned about the distinct products without any duplicates in this our data sets or in this our table. There we use the distinct operator with our counts. That is, this is what I'm saying. Counts distinct. Let me write that in caps. Distinct products. Then let's run this. As you initially saw here, that's the total product in our product name that we have in our product table is there are 150. But without any repetition, we want to count the number without any duplicates. So you use the distinct, let's say Control Enter and see. As you can see here, we have 148. That is, we have 148 unique items. That is unique products, unique product name in our product table. However, total, so as in generalizing it, we have about 150. So that's the advantage of distinct over there. We can alias this as, let's say, distinct product. So we can, that's about that. As you can see, this is an aggregate function, as we earlier made mention of. That is, it aggregated all those values. That is, it compresses all those, as in the counts. It counted all those rows, about 150 rows. It's what it summed them up, or it counted them up, I mean, to a single value. It compresses them towards a single value, and that's what we mean by aggregates in SQL generally. So another aggregate function that we'll be looking to is the, let's see, is the sum function. Sum function, as it sounds, that is used to add up numerical data. Let's check our products table again. Take for instance, we want to know the total price of the goods being sold generally in this our products table. We can simply leverage the sum function for that. Let's say sum. Then that is sum of the total price, right? So that will be price. Then let's say the total price. This is total price. So, and let's run that and see what we have. Control Enter. As you can see, this is the total sum of the prices, of the products in our product table, about $61,434.54. We can also round this up to the nearest O number. So you can you can simply leverage the round function. That is mixing the round function with the sum function together. So let's say we want to round this up. Let's say round this particular to let's say O number. If you like, you can specify 0 for it to round it up to O number. And if you don't specify anything, that is without any 0, just round alone, it's assume, MySQL assume that you are rounding it up to the nearest O number. So if you run this, you still have the same results as putting 0. So to the nearest O number, we have $61,435 dollars in total for the prices of our goods or our products in this table. So that's that. We can also use another function, another aggregate function here is the average function. As we know, average is just taking the mean of a particular data, that is the total numbers of the summation of the total number of the feed divided by the number of the feeds in there. Take for instance, we want to find the average price of a product in our product table. This particular part. That is, we want to check the average price of our products in our product table. We can simply use the average function. That is, let's say average of price. So we can simply say this is, instead of total, let's say this is average price. So let's run this and see what we have. Control Enter. So the average price of products here is about 409.563600. As you can see, there are many points after decimal place. We can simply round that up to the nearest whole number. So let's run that again. As you can see, the average price of the goods being sold in this product table is 410. That's the middle value, or the middle number for that. Let's move ahead and see other aggregate function here. We also have the max and min, that is the maximum number and the minimum number. So we can have, let's check the maximum price of goods being sold here. So we use the max function. We would like to display the goods itself, so that's to know the name of the highest products being sold. Let's say the product name. Let's select the product name. We can also include the category of the product. Then finally, we'll need the maximum price of that particular goods. Let's change this to max price. So let's run this and see what we have. Control Enter. Oops. The set in aggregated query without group by expression or select list contain this. It shows an error here. Why? As you can see, in a product name, our product name is, there are about 150 of them or 148 of them unique value in there. That is, every row has a unique product name, except let's say 2 of them. However, category, let us run the product table to see what I'm talking of. However, category, we can see that we can categorize most of all these product name into a particular category. Take for instance this first row over here, it belongs to the beauty category, and also the fourth one over here, that is Southern Fragrance, it also belongs to the beauty category. Likewise, there are some products like this second one, Those Fitness, the product name belongs to the fitness category. It belongs to the sports category, then the ITS Team Sports product name also belongs to the sports. Likewise, the Level Yoga also belongs to the sports categories. So we can only aggregate them based on that category, not with their product name, because product name, they are unique for each entry in our table. I don't think whether you get what I'm saying here. Let's remove this particular product name here and see what we'll have. Although we also leverage use by, as in group by, with it, in order for us to have the maximum price per group, per category, That is, we want to group by the category, and it will display the maximum price in each group. That is, in beauty group, which products, as well as the maximum price in the beauty group that we have, the maximum price in the sports group, in the sports category, likewise beauty, electronics, and the likes. So let's simply use the group by statements here. Group by. Let's say we are grouping by the category, and let's run our query and see what we have. Control Enter. Now we can see that per category, these are the maximum price of the goods being sold there. Like in beauty, we had about 487.26. in sports, in home, electronics, and apparel. That is, we only have about 5 categories of products in our table. So we can also use the sum, that is to know the total sum of each product being sold in each category. So we can use the sum function also with that to check. Control Enter. We can see these are the total. So there we can know the highest number of products being sold. Checking through this, we can see that electronics has the highest number, as in sum, the total sum of electronic gadgets. This particular business, this particular e-commerce, mostly sells, as in it makes its largest huge revenue from electronics products or electronics gadgets. So that's that about that. As we can see, we can also use the minimum. I think that's the last aggregation function in our list. These are the minimum price being sold of the goods being sold. So that's about that. That is using some function which select. Let's move to the next agenda here, which is the where clause. Let's say we are selecting everything here with the condition where, let me write that in caps, where, let's say, as I said earlier on, that as we can use all these functions, the string, the numerical function, the date and time, the aggregate function with select statements or select clause, we can also use it with the where clause. Let's take, for instance, we are only concerned about those products that are being launched in 2023 alone. The products that are being launched in 2023 alone. That means that we are focusing on a particular year. We can simply leverage the year function, which is a date time function in our SQL, to do that. And how can we achieve this? Let's say select all from products, that is from the products table, where the year of the launch date, that is launch date, let's say equals to, we're only focused about a year, that is 2023 alone. Take, for instance, as our case being, and let's run this and see what we have. Let's run this 2023. All right, control enter. As you can see now, all these products here are being launched in 2023. We can't see any other years here. We can't see any other here over here. All these products are just what's 2023 alone. Likewise, we can also decide that, okay, we're only more concerned about products being launched, let's say in January, for instance. There we'll select the month. We'll use the month function instead of year. We say the month, then we run that, where the month equals, let's say, January, which is 1. So control enter. As you can see in this month column over here, everything is what, 010101 downward. Or a specific date or a specific day also, you can also select that by saying, okay, when the day is equals to let's say on 3rd or on 23rd. You can also use other functions and operators with the where clause also. Take, for instance, the popular operator we do use with where is the equals sign. We have many logical operators aside equals, as in the equals sign. We have the greater than, we have the less than. We also have some logical statement like and, or, not, like, is, and the likes. Let's just as in brush over that and see through that before calling it a day. The greater than sign, the less than, the equals to, we have the and, we have the or, we have the not, and the likes. We also have like, we have in, we have between. There are lots. So, but let us just play with some of them over here. Let's say, let's go back to our products table. Let's say we want to find a particular product that is greater than $100. That is, the price of the product is greater than $100. However, it's greater than $100, for instance. So we can simply say where the price, that is the price of the product, we're only concerned with the product that are greater than $100, is greater than what's 100. So we can simply run this and see. As you can see here, all these products below here are greater than 100. We might also decide that, okay, it might be greater than $100 but less than $200, for instance. That is in between 101 to 199, right? So where price is greater than 100 and the price also is less than 200. So we can simply run this and see what we have. As you can see, the highest product here is what we have as in 199, 197, 102, 103, and the rest. Or we must decided that, okay, it must start from 100 and ends in 200. There we use greater than or equals to 100, but less than or equals to 200. So let's run that and see what we have. Control Enter. So there we'll find out that we'll have some products or some products that their price is what is 100 on dots, or some products in which their price is 200 on dots. The AND logical statement returns true condition. That is, the both conditions must be true for the AND logical statement to perform its function. That is, the price must be greater than and equals to 100, and also must be less than or equals to 100. The both conditions must be true. That is, any table that it will, any as an output that it will be displaying, it will obey these two conditions. We can also use other conditions like the OR logical as an statement, or that is, we are telling our query here to return prices that are greater than or equals to 100, or prices that are less than or equals to 200. If either of these condition is true, it should return it. It's not a must that the both condition must be met. So far as one of them is true, it will return it. That's the function of the OR logical statement. So if you run this, you have some outputs in there. Take for instance, we are seeing something like 263. We are seeing something like 347, 779, and the likes. You find out that these are greater than 200, right? But we've told the query that so far as it obeys one of these two conditions, it should return the result. And one of the conditions says that the price should be greater than or equals to 100. And this price is like 340 something, 779. They are greater than 200. They are greater than 100, I mean. So definitely it should return them back because it's true. Even though it's not true with this second as in condition that our price is less than or equals to 200 for this particular 347, 779 and the likes. And there also you can also find out that you have some value like 663.10 over here for these products here, the yoga products. 63.1 is what is less than 100. That satisfies the second condition. So the OR logical operator usually operates in such a way that whenever one of the condition is true, it returns the result. However, and the both condition must be true before it returns any results. Is that clear? You can also use the NOT. That is where price is not 100. For where price is not 100, you can simply select as in use the exclamation mark and equals to. What this particular sign means that display all the prices of the products that is not 100 exactly. So far as is 199, so far is 99, that is not up to 100. It must not be 100. It can be any number, but not 100 exactly. So running this, we have something like this. As you can see, all these prices over here, we have 263, we have 63, but nothing like 100 exactly on it. So we can also play with other logical operator with where. Then you can also select, you can also use the between as an operator also. We can also use the between operator in our where statement. Take for instance, we are considering the price range of products between, let's say, 200 and 400. We want to know those products that falls into that category. That is between $200 and $400. Let's say select the product name. That is product name. Let's say category and the category of that product. And let's say price. Let's select those three. Then where the price is between, let's say 200 and 400 for instance. So when we run this query, it will return those products name their category and their prices that will be in this range that we've declared, 200 and 400. So let's simply run the query and see what we have. Control Enter. All right, as you can see, all these products being displayed here, they are in between this condition, 200 and 400, not less than 200 and not greater than 400. Like this first product over here, we can see is 263.92. Likewise, this other one, 367.71, and the rest. So that's the function of between. We use it to declare an interval for our feeds. That is in between this, as in from this to this. That is, we use it for range. We can also use the between also in date function. Take for instance, we're only concerned about those products that we sold from, let's say, the 1st of January to 31st of December in 2023 alone. We can simply still leverage that by simply saying, okay, the products, the category, the price, let's also display the launch date. The launch date. The launch date between, let's say, 2023 January, and put that in as in column, as in quotation, I mean. So 2023 December 31st. And let's display this and see what we have. Control Enter. Oops, there's no any product that obeys this. Oh, we said where price, there's nothing like, as in price doesn't have that range of dates. So we're supposed to use launch dates instead of using price. So where the launch dates is in between these two dates. So let's run our query again and see what we have. Control Enter. All right. So as you can see here, all these launch dates over here, they are those dates in between January 2023 and December 31st, 2023, that same year. We do not see anything like 2024 or 2025 products over here. So it's displayed their products name, the category, the price, and the launch dates. So that's about that. In our next class of this, we'll be talking about the group by statements and the group by clause and the having clause. So see you in the next class. Thank you so much for taking your time in watching this video. See you in the next class. Thanks.